Hello, folks. Welcome to another episode of AWS Show and Tell. I am Anil Nadiminti, your host, joining from New Jersey today. A brief introduction about myself is I'm a senior solutions architect here supporting enterprise customers in the fintech space. And today we have a topic, again on agents that can self-improve. So let's chat about that. I'll ask Shoaib, Bharati, and Vivek to introduce themselves, and then we'll go into the details.
Hey folk, I'm Shoaib. I'm one of the founding members of AgentCore Evaluations and Optimizations. I'm a software development manager. I'm right here with my team. They're sitting right there, the builders.
Where you based out of, Shoaib?
I'm based out of the Seattle office. It's right by the spheres. I can look it at the spheres right outside my window.
Nice. Thanks for the intro. Bharati?
Yeah, hi everyone. My name is Bharti. I'm a senior GenAI data scientist in the Worldwide Specialist org, and I'm supporting AgentCore, so I'm in the GTM side. I'm the one who bothers Shoaib and Vivek the most. I'm sitting right across the street from them.
Nice.
Hi, thanks, Anil. Hi, everyone. I'm Vivek. I'm a product manager in the AgentCore team. I drive observability, evaluations, behavioral analysis, and recommendation set of capabilities for agents. Excited to be talking to you all about self-evolving agents and the set of features and capabilities that we are building and the roadmap of what this space looks like. Happy to be operating in this and talking to you all about this.
Yeah, thanks, Vivek. So, folks who are joining live, let us know in the chat where you're joining from. We know you're joining from everywhere, like across the globe. So please put it in the chat. Let's talk about today's topic, right? So we, in this live stream series on AWS Show and Tell, we've chatted about deploying agents, bringing them from POC to production. And along the lines, we have shared how to get into the details of observability, being able to evaluate the agents, right? So, but in today's topic, we are going to understand how we can build agents that can self-improve. Bharati, Shoaib, and Vivek are going to talk and explain to you folks how this can be possible using the features within AgentCore, right? So think of agents that you're putting in production. How can you get insights into whether the agents are doing the right tool calls? Is the system prompt something that can be optimized, right? So I let the team dive into this. Bharati?
Awesome. Yeah, thanks, Anna. We're pretty excited to talk about this with all of you today. So we have a lot of features and capabilities on AgentCore that help you to get started with an agent really quickly by just creating a harness and putting an agent in production. That is the easy part. Right now, the difficulty is actually knowing, is your agent doing what it's supposed to, and then catching when it's going to fail, and then constantly monitor it in production and make sure that it's not drifting. Right. So this difficult part is what AgentCore evaluations and the optimizations is going to help you with. And we have a ton of features, so we're going to go through them step by step, but we have to start in the beginning with observability. I know Vivek and Shoaib are spearheading these features, and we just launched Insights last week as well, so it's pretty exciting. Vivek has been foundational in designing this whole thing. Vivek, do you want to add something about Insights before we get started?
Lots, but Insights, basically the aha moment for to get the idea for building Insights was just looking at the observability dashboard, and we have one of the great ones, AgentCore observability. But the challenge was just looking at that and realizing, oh, I've got hundreds and thousands of sessions collected, multi-turn conversations, and I don't know which one to pick or click into to get the biggest bang out of my buck if I'm investing the time to analyze certain things to identify what's going on, what are the failure fault lines, what is happening with my agents, how can I go beyond just looking at 4xx or 5xx errors to find the subtle, implicit, or hidden ways in which my agent is failing. And then if I click a few and I start to realize there is a pattern in which my agent is failing, how many does that take? How many clicks do I need to make before I start to realize, oh, see, there's a pattern. There's beyond just endless filtering, there is a way for me to identify patterns. And if by chance I detect I go through 20, 30 scores of sessions and I am able to identify 3 or 4 patterns, then I don't know which one to prioritize first in terms of going and fixing those issues, because I don't know which one is impacting 60% of my users versus 3%. So I might be optimizing for edge cases versus going and working on really needle moving stuff. So staring at that and hearing this from so many customers is what um, push me to, yeah, we need a solution for this that detects these implicit, subtle, or hidden failures that agents could be failing. So for example, it says that yes, this product is present when it's not even in the inventory, so it did not invoke the inventory API, or it booked 2 people on the same seat in the airplane. So evaluation could tell you, yes, the right process was followed and the result was achieved, but it was the wrong result because 2 people got booked on the same seat, and so on and so forth. So a service that detects these hidden, latent, or subtle failures, root causes those for you, and creates clusters to help you understand the blast radius of which issue is impacting how many users. But this got built on observability, evaluations. It's a powerful product in its own right, and all of this, these two signals, whether that's evaluations for known dimensions or insights for hidden or latent failures, give you the signal to go and improve your agents, for which we have the recommendation set of features, which super excited to talk about. Yeah. All in the
Awesome. Yeah, thanks, Avik. I think we're going to start at agent observability, because this is the foundational layer that you need for both evaluations as well as optimizations. So we're just going to cover the basics a little bit. Agent ops is actually very, very different from any of the ops that you would be doing. First of all, you have a non-deterministic system running the whole show. And now this LLM is also going to be making API calls. It's retrieving data from RAG systems. There are different reasoning paths that it's going to take. And also even the active context in terms of memory it is storing, right? So there is a lot of different moving parts that you're trying to manage. And this is the core issue of what also keeps developers up at night. So there are multiple things to worry about when you're trying to observe and monitor your agents. Shoaib, I know you work firsthand on a lot of these problems, both internally developing agents at Amazon as well as developing the solutions for our customers. Do you want to walk us through it?
Yeah, I just wish there was that magic crystal ball which we could peer into and then spot all of the failures that agents can go through. And the analogy that we use for agents is we try to call it artificial intelligence. So when the word intelligence is tagged onto it, we expect it to choose its own path, we expect it to do its own thing. And what kind of guarantees do you have when there is something that it's doing its own thing? This Before we go into the guarantees itself, we have to measure some sort of a guarantee that can be produced. You first need to be able to observe what it's doing. It's only then that you can start evaluating, you can do any of that. So it's a combination of the magic crystal ball that doesn't exist, to be able to see what agents are doing, and that is where observability comes in. And then it shows you all of the activities that it's doing through traces, and eventually we'll be able to achieve all of these goals that we are seeing on this slide.
One of the things that I've seen often is you bring an agent into production very quickly. Anil, tell me if you've also seen this among your customers, right? How
Yeah.
many of them are doing evaluations and doing them properly?
When I talk to customers, they're asking me for sure, right? Is the agent really doing the call that it's supposed to be doing? Are we spending the right amount of tokens? Is is the agent actually being helpful, right? So these are the calls and questions that the customers are asking us, and they're definitely looking at frameworks to understand if they can evaluate the agents against certain criteria, right? So this is something that we are seeing in the field, Harvey.
Yeah, exactly. But this is also a difficult problem because you're actually translating your business criteria into what your agent is supposed to do into actual metrics, like data science metrics. And for all of this, the groundwork is having observability in place. So typically what we're doing with agents to do it is first observe what it's doing. We keep talking about observability, but then there are different steps in the whole process that developers are focusing a lot of effort on. We're going to keep referring to this as the inner loop, outer loop, and production loop, and we're going to go into it in depth. And this gives you the evaluation framework on top of which optimization sits. So I'm just going to skip ahead and first, let's look at observability, right? So AgentCore observability gives you this visibility to operate your agents and see what they're doing. So you can build that trust into knowing what it's doing. There are some key concepts that we need to understand. So we want to just align quickly on the tracing vocabulary. So you have a session, for example, this is when a user comes in, starts chatting with your agent, and then this entire conversation or this interaction lifecycle is one session. So let's say
the session is abstract concept. It is something that we manufacture out of what an agent is doing. I just want to establish that there is no such actual thing as a session. So there is a session ID, but it can be anything that you can tag on to calling that as a session, which an entire run could be.
Yeah. And what is the reason behind doing this, Shoaib?
We want to have units of measure. When we are trying to measure something, we want to compact the behavior into a certain loop. A total end-to-end flight booking could be a session. A coding loop where you gave a prompt and the agent came back with a design document could be a session. Depending on the flavor of the agent, we want some sort of abstraction that is measurable, packageable, and hence there's an existing concept called sessions in all of the instrumentation libraries that we use. It's an abstraction, and there's no such explicit thing that's defined as what a session is.
Yeah.
Colloquially in the industry, what we are standardizing or at least converging on is just using the term, as Shoaib said, there's technically not a very defined globally accepted definition, but in the industry, what we typically see is one conversation related to one topic, turn comprising of all the turns of a given conversation. All of that combined is called a session. So you can think of one conversation, one full conversation could be is equivalent to one session, and one turn of that is what Bharti is presenting as a trace, one input output, and what happened in order to generate that output, all the steps and all the API calls and everything that in between, be able to return that one response back to the user is a span. So just as conversations can be never ending, like we have this conversation and it stops, and then 3 days from now Anil says, hey, remember that we were discussing about this, and that's the next back and forth. So technically a session can never end, but at the same time the session is when we typically talk about it, it's one conversation related to.
When we touch upon span, I'd also try to bring out another terminology which we use a lot, which is a turn. A turn is simply a back and forth exchange between you and an agent, which is the actual chat log. If you put it that way, where there's a user turn and there is a agent turn, it's literally like we take turns to talk. And some of the span, an example for a turn is a span. And there are many other spans that exist, like tool calls and tool responses and thinking spans. There are many components that are put together and form a session.
So what about the subspan then, right? So we know that span is if you take an example of a flight booking reservation, right? Flight reservation, we're talking about session, the traces, right? So if you can break that down as well.
The subspan, it varies based on what the span itself is trying to indicate. So if you look at this specific example, there is a span that says process change or even a generate response span, and within that you have the LLM call, the tool call, the database call, and the final response. The components that put together that form the main line item which is being measured or which is being tracked as part of your session is called the subspan.
Excellent.
So the subspan just gives you a lot more granularity, right? So you can see the latency, if there were API calls with a specific error that came out of those API calls. So you might see some subspans depending on how those tools have also been constructed.
Exactly. And all of these are important because we want to be able to measure and see what's happening within the interactions of a user and an agent, right? So can't wait to get to the next parts in the conversation, Bharti, here.
Yeah, so this hierarchy is important because this is what we're going to use to debug the agent behavior. And it also makes that whole process a lot more structured. So let's look at agent core observability, right? So for a lot of observability is really looking at that agent framework, the OTel spans that come out of it, and really monitoring how has the agent interpreted the user request and then called the different tools. However, when you have an agent in production, there are so many other different components that contribute to that agent behavior. It can be hosted on runtime, but it's going to be fetching context from memory. It has its identity that is propagating. It could be interacting through a gateway through to models or tools, and invoking a lot of different tools outside of it. And agent core observability actually gives you the full picture. It isn't just focused on the agent framework alone, but all of the agent core services, it gives you detailed visualizations of each step in that agent workflow. So this helps your developers to inspect like all the execution paths. It's show you all the intermediate outputs, and then debug the different bottlenecks at each level of agent performance. So let's take a look at this, right? So you do have like different phases that happens. One, your user query comes in, it's invoking your runtime. Then you have like a OAuth token that is retrieved, which lets the agent now invoke the gateway. And then on the gateway, it decides what tool to call. You can also see this part on policy right here. So we did have one of the sessions on AWS Show and Tell talking about agent core policy and how you can use this to control interactions between your agent to its tools. And so you see the decision of policy explicitly allowing it to call the tool. And then now it enters this loop cycle of your agent itself, and tells you when it's invoked, which tool it invoked. And you'll see a deep dive then again also the response from the tool, and then how it generated the output back. So you're essentially seeing from the user query to the entire trajectory that was followed by your agent, not just within the framework, but beyond all of the services that are interacting as well.
And folks in the chat, I've dropped a link to the deep dive series, so feel free to go to that, and you can know a little bit more about each of those items that Bharati has spoken.
And Anil, to your point, the first hierarchy or the first level of bullet, the leftmost one, that would be a span, and every nested bullet inside the leftmost one would be considered a sub-span. So when you invoke a tool, a weather tool to get you a weather, and then that invokes an API, an external API, that would become a subspan of it.
Excellent.
So given that agent core observability is now surfacing all of this to you, now you have a good foundation to start doing evaluations. That's where agent core evaluations comes into play. And I'm going to actually allow Shoaib to explain like these 3 loops to help us like develop an agent and then take it all the way to production. And then we will go into each of those different scenarios and talk about what features help you the most.
Hey, Bharati, I'm going to step back a little bit just so I want to drive this common misconception in when agent builders, they try to build an agent and they try to observe it and try to evaluate it. This is a common misconception or a pitfall that builders fall into is agent instrumentation. So the trace in the previous slide, which Bharati showed with all the spans and all of that good stuff, doesn't just show up magically in your observability framework. Yes, there will be some set of spans and traces that get emitted, and you'll be able to view some portion of it, but the degree or the extent to which you'll be able to measure is driven by how you instrument your agent. And instrumentation like a speedometer on your car or the pressure sensor on your tire, it's similar to that, where you want the agent to be emitting each of those subcomponents, and you have to make sure you're setting the trace levels and all of the settings within your agentic framework to be able to emit traces at that granularity, so that we'll be able to measure it further down in evaluations. Some of the frameworks that you would use to instrument include ADOT, OpenTelemetry, and OpenInference, no matter which agentic platform you're using. and agent core evaluations. We are working towards supporting all those. Yeah. So now we
Yeah.
can. Yeah. Go ahead.
So does that mean your agent has to be on runtime then, Shoaib? Like if I, or can I also instrument it myself with an agent in a Lambda or a ECS, EKS? How much do we support that?
That's an excellent question. Um, Agent core evaluations, since the focus is on agent core evaluations, it is very easy to misconstrue that agent core evaluation supports only agent core runtime as a source. Agent core evaluations, interestingly, supports all types of agentic workloads that run on different types of compute, including Lambda, ECS. All you need to do is make sure you're following the guide that's there in our documentation on how to instrument it and emit those traces into a CloudWatch bucket, into a CloudWatch log group, and agent core evaluations will be able to evaluate them for you, and you should be able to use the entire spectrum of the offering.
So when you talk about Shoaib, when you talk about the emitting the traces, right? So is it more like a configuration, or is it more like something in the code that you have to do? Because oftentimes we want to make sure that the traces are available within the cloud logs in this case.
It's a combination. You will both do a configuration and you'll also add the right decorators in your agent description or the agent definition. And that will allow these traces to be emitted. It is very easy to, the proof of concept agent that you're setting up will not natively have that set up. So you will need to explicitly go and follow those steps. Otherwise, you will end up in a world where the traces don't have sufficient details and you are unable to get an evaluation result.
Um, It sounds complex, but it's actually pretty easy. I've done this for a Lambda function. We also have a lot of like code samples actually on our GitHub samples as well. So if you look at integrations and agent frameworks, we show you hosting it on ECS, hosting it on Lambda, and then the couple of steps that you need for ensuring, one, your agent's emitting traces, two, you have ADOT to collect it, and then you start seeing your traces and observability. That being said, I'm pretty excited to move on to evaluations. Sure, if you're ready. I'm
Yeah,
going to
I'm
give you a
ready. I'm
scenario.
ready. Yeah,
I
go for
have
it.
an agent.
Go for
I'm
it.
developing it. Tell me all the steps where I need to do evaluations.
Yeah, I think this is the part that you get most excited when you're showing this to customers. This is a concept for builders. You should be able to directly map this to the pre-existing traditional engineering workflows, builder workflows of software development, and apply those concepts in the agentic space as well. So I will try to build as many correlations as possible. So we want to introduce the three concepts of inner loop, outer loop, and the production loop. So as an agent builder, when I'm building a proof of concept, um, I have written my prompt, I've written my tools, I've set it up, I'm able to invoke my agent, starting chatting with it. It's a travel agent. Hey, agent, can you book a flight for me, or whatever workflow that I've built? It works, it looks great. Now I want to make sure that it's able to run test. I want to be able to test it across a dozen scenarios. So it's right on my dev desktop, right on my builder and IDE. I want to be able to test 50 scenarios. I could just use LLM prompt to generate 50 scenarios, and I want the agent to run through it, and then I can see what it's whether the agent is able to take that input and give me an output that expected, and I'm able to measure that whether the response is as I expected it to be. So that is your inner loop. This is something that builders will be doing iteratively on their IDE at build time, just before they are about to check in their code. This is something which is a hygiene practice, which you have probably already have set up in some form or nature. And Agent Core gives you build native tools, which Bharati will touch upon shortly, on how you will be able to achieve your inner loop. So the inner loop happens on your IDE. This is before you deploy anything, before you ship your code. It all happens on your local environment. The outer loop is basically your CI/CD pipeline. This is the equivalent of your integration tests, or any of your tests that run on your pipeline to be able to work as your CI/CD gate. And the CI/CD gate is essentially a guarantee that ensures that your agent is able to hit a bare minimum set of test cases, which um, which will give you the comfort or give you the peace to be able to sleep in peace. This is usually driven by a few thousand test cases or a few hundred test cases at minimum, which you have set up on your pipeline and acts as a gate before it gets deployed. The agent core also provides tools for you to be able to achieve this using data sets. I don't know if you'll have time for that, Bharati, but we will we'll make sure that we put the links out on the chat for you to be able to use data sets and set up all of those 50 100 test scenarios to get confidence. It's just similar to a traditional code delivery pipeline. That's your outer loop. The production loop is when you don't know what you're looking for. Your agent is running in production and you are not actively going and running tests on it. But then, since the agent workflow is so non deterministic that you don't even know what you're looking for, and that's where monitoring and the insights concept, which Vivek spoke about at the beginning of the show, that comes in and that brings out types of failures which you haven't been looking for, and then eventually go into the optimizations phase. So these are the three loops which you want to be aware of. This is a conceptually something which we had to think through as we were building agent core evaluations and optimizations, and we are happy to share it here.
Awesome. Yeah, I think we're going to look at some demos and kind of also show you how do you set up like online evaluations for your production loop, and for the inner loop, like how does batch evaluation help you do all of this. So we have go explore your console on Agent Core evaluations, and for each of the different things you're trying to do, you will see how you're able to test your agent when you're developing it, then build them as data sets, both you're creating simulated data sets as well, and then running it, and then doing online evaluation as well. But now the question is, let's say you're able to do all of these evaluations, but what kind of evaluators should you be using? And even for this, we have like a variety of evaluators that help you. I'm going to allow Vivek to walk us through the different types of evaluators we have.
Thanks, Bharti. So as we discussed, the different layers of granularity within a conversation. One is a full conversation. What was the key takeaway from that conversation? In the context of agents, like every conversation starts with a goal in mind of the user, that this is like book me a ticket, or I'm planning to travel, or I want to buy a product. So one evaluator could be, was the goal met, and that needs to be applied at a full conversation level. Then each turn of that conversation, whether, hey, like my name is Vivek, I'm planning a trip to Seattle, help me with that. And then the agent responds, okay, what are you looking to do here, when are you coming, and what are your interests, and so on. And so that back and forth happens. So each turn of that conversation could be evaluated for, was this response correct, was it helpful, what is contextual, what was it biased, or any toxicity in it. And then at a span level, when I asked for it, hey, go book me a ticket, did it pick the right tools at a span level, execution level? Did it invoke the right APIs? And when it was doing that, did it pass the right set of information, which in this case would be parameters, to the tool to be able to do its job properly? So if it's a tool that writes to a DDB or invokes certain things, then it needs certain set of inputs for it to do its job, and that those parameters. So within Agent Core evaluations, we have evaluators across these three levels, built-in evaluators that are templated prompts that work with LLM as a judge to evaluate the performance at each of these three levels, whether the agent did the right thing. These are generic enough to be applied to across different types of use cases, whether that's goal success rate, which is applied at a session level, full conversation, or 10 evaluators that are applied at a trace level, which is one turn of that conversation, or two evaluators that are applied at a span level, tool selection accuracy and tool parameter correctness. So these are the built-in evaluators. Then we also have the flexibility for customers to define their own custom evaluators, so domain-specific evaluator, which might not be generic where generic evaluators might not work. So conversation flow quality. Now there's no standard way of like what good conversation flow quality means, or something more bespoke for medical transcription or something like that, in which case customers could define that evaluator, that this is the definition that I would want this LLM as a judge to use to perform this evaluation, and this is the scoring rubric. And um, I could go on and on the like the differentiators of the online evaluation piece, like but yeah, I'll hand it over back to
So,
Bharti.
so
But
maybe a question, right? So when somebody's using evaluations, can they pick a model that they can actually use to do the evaluations?
uh, yes, and like for and but we using a model introduces a lot of puts a lot of heavy lift on customers. First things like at infra level, you need to build and maintain that pipeline of hey and deal with the rate APIs, throttles, capacities, and that's one of the differentiators that we have built with Agent Core evaluations, where some of the other platforms you need to bring in your own inference to perform those evaluations. An
Mhm.
agent core evaluation is a managed service which takes care of the inference for you. And beyond just the infrastructure piece, which is a very big lift in itself, the real differentiation comes from applying the evaluators at the right level. More importantly, doing the context management across a session or conversation, which could span multiple turns, but LLMs have their own context window. You need to graph prune and cut the right and create the right context to be passed to that LLM to perform effective evaluations. You can't just simply cut it into a context window and pass, because that would not have the
Mhm.
right context for evaluation. So applying the evaluator side at the right level, passing the right context, doing the right graph to pass the right context. When do you go in and pick up a session to perform evaluation? Because as we discussed, sessions can be never ending. So what is that querying mechanism that you build to go in and pick the right session to perform evaluations? All of these needs to be taken care of, which is the managed part that is resonating a lot with customers with agent core evaluations. Otherwise, if the inference is on the customer side, as you said, like you can bring in your model. Agent core evaluations also allows you to do that, pick your own model to perform evaluations. But in this case, the inference piece and all of this, customers would have to manage themselves. Versus use, we also offer a managed way of running this, where you none of this lift is on the customer. All they need to do is just tell us this is the agent, which tells us, hey, here is where we'll find the traces, pick the evaluators, whether those are built-in or custom evaluators, and tell us a sampling rate that, hey, 2% or 10% of my kind of conversations I would want evaluated versus 100%, because LLMs cost also scales with that.
Mhm. Makes sense.
There are two things that I'd like to add to Vivek now that we are looking at the menu of evaluators that are available for putting in all of your inner loop, outer loop, and your deployment gates. The one value add which Vivek also mentioned is the level, which, if you remember, we correlates to the same discussion we had at the beginning of you having a session, trace, and span. Agent Core is able to parse that for you, pick just what is needed to be able to hit that evaluator with. For example, for a two-level evaluator, which is tool selection accuracy, you don't want to hit it with the entire conversation load and then consume the um, tokens required for it and then get inaccurate results. Agent Core, the online portion of it at least, is able to extract that for you and make the right level of calls, and that's a heavy lift that infrastructure does. The one thing that I'd like to stress, the that I'd like to highlight to the audience is the support for ground truth. Now, when we are, I mean, the LLM as a judge makes our life easy. Yes, we just say, "Hey, LLM, tell me whether this worked or not." But the ground truth is the evaluators. If you the second last column are the ones that give you some sort of a guarantee, and which is what I would expect anyone building a real production system to heavily use. It is as simple as, if I ask my agent A, will it respond with B? And that's your ground truth. I asked A, my agent responded with B. Is B the same as B? Maybe B is the same as B hash, but B should not be C. And that absolute comparison is what the expected response APIs. You can also do some sort of assertion on the entire conversation itself, which is your first one. That's a session level ground truth that says, in my entire conversation, the agent should not have done X, or the agent should have done X, Y. It's an assertion at the whole session level, and that expected trajectory is the one where we we evaluate whether the agent is calling the right tools in the right order, and we measure that. It's not an LLM based. That's the only one that's programmatic, and there are no LLMs behind it.
So once once we understand that, okay, there's an evaluation that's done, what's upon a developer or a builder who's actually maintaining this evaluation? I mean, this whole agentic harness. What do they have to do, right? So I know maybe this is a question for the end of the session here today, but as we get into the details, right? So okay, we're looking at the evaluation, the numbers are coming up. What entails like the next steps in the developer journey there?
So that's where we touched upon the three builder loops.
Mm.
You would as a mental model, when you are building something, so first time you're building an agent, to get some sort of comfort in being able to ship into production, you would start with just a bunch of evaluators. You could use some of our built-in evaluators, just check boxes, select them and have them run, or call them on an on-demand basis, saying here are 30 API calls to the basic evaluators which are built in. They have a pre-built canned prompts, and get some confidence out of it to ship your v.1 of your agent to put it into your test group. But as you expand the capabilities, you want to move into being able to set up CI/CD gates, and that is the next phase where now you're serious. You're now trying to get this into production. You're trying to get more users on it. You're scaling it from 10, 100,000 users. At that point, you want to enrich the number of test cases you have through the concept called data sets. We didn't get to touch upon it in this discussion. I don't know if you'll have time, but the data sets allows you to give a predefined set of inputs, outputs, cross verification, ground truth as something that is stored within the service on an S3 bucket. And you'll be able to run evaluations against it, measure the scores, and set up a CI/CD gate using GitHub Actions, for example, and then decide whether this actually goes to the next step into your
Yeah, can't wait to see this in action here next, right? So Bharati, do you have some demos for us?
Yeah, absolutely. Let's actually look at how easy it is to create these evaluators, right? So Vivek did mention we have these built-in evaluators, and you asked, can I choose my own model? So this is where you would actually create like a custom evaluator, and I will show you. So to create a custom evaluator, you basically need three things. One, you need a crystal clear definition of what your evaluator is supposed to do. Here, I'm actually choosing one of the pre-created built-in evaluators as a template, and it loads in the instructions for how to evaluate. So as you can see here, it's giving a very clear objective. And then it's going to, when you say use this conversation text from the user and the agent, and this is what is going to retrieve from the traces, if it's a trace level evaluator, or session, if it's all, it'll pull all the traces of that session and feed this into the evaluator. And here on the right, you can see we're actually picking a model. So any of the models on Amazon Bedrock are fair game to use as your custom LLM as a judge model here. The next step is, the third one is defining a scale or a rubric. So essentially, you want to give a very precise definition of, if you say the LLM as a judge is going to say 1 as evaluation score, what does that mean? What should the agent have done that it's getting rated as a 1? So give a very precise definition for that scale itself. And the moment you've done this, you actually have a custom evaluator ready for you. So you have 13 built-in evaluators, which brings in a lot of these definitions for you to reuse, but you can also go ahead and customize it. Another thing to think of is you have not just the ability to create LLM as a judge, but you can also create any deterministic code that you have, put it in an AWS Lambda function, and you can directly register that as a evaluator as well. This gives you the flexibility of both non-deterministic evaluators, where you have a lot of reasoning that is happening that you can't really codify, but also having deterministic checks on your agents. What is a good example of a deterministic check, Shoaib?
The Lambda evaluators were built keeping specific industries in mind which need accuracy over everything. LLM as a judge would treat $300 and $300.25 as just the same, but they make a big difference when it gets credited to your bank account. And specifically for industries which are very sensitive to accuracy and like tax and finance and healthcare and medicine dosages, those kind of use cases cannot just rely on LLM as a judge, and we wanted to make sure we have evaluators. And there is also use cases where you would want to do custom API calls to be able to achieve a certain goal or to measure it against your production data examples. For example, let's say that you want to make a call to your Dynamo database and it needs to be on a real time basis based on the time of the day, what have you. You can get very creative about what you want to achieve, and we wanted to support all those use cases. Anything fits in a Lambda can be evaluated, and that's why we came up with the Lambda evaluations.
Perfect. So now this was your production loop, right? So let's look at how it's actually going to show up. So first we're going to set up online evaluations. So let's say create an online configuration. You're going to specify so either an agent endpoint. Actually, I'm going to pause this and tell you very quickly. So we did talk about AgentCore observability precisely for this reason. If when you pick up the agent runpoint, what it's doing is automatically taking the logs related to that endpoint. So you can see I've picked up a demo travel agent, and then it automatically chooses that specific CloudWatch log group. Now, if your agent is not on AgentCore runtime, you can also directly point to the CloudWatch log group where your agent logs are getting emitted. So this is where you also have like a lot of flexibility in how you're using AgentCore evaluations.
The two options on top, that's what allows you to choose between AgentCore as a runtime and your bring your own compute as a runtime, and we support that across the board. As long as your data shows up in a CloudWatch log group, we'll be able to evaluate it and use all of the features that evaluations and optimizations offers.
Then you can pick any of your both built-in evaluators as well as your custom evaluators. So I'm going to pick correctness, helpfulness, faithfulness. So essentially think about those 3 dimensions, right? On the session level, what you want to measure, on the trace level, what you want to measure, and on the tool level. So then you have a sampling rate, and this is the percentage of production traces that are getting sampled. And now your production loop is already set up, right? So it's as simple as defining what evaluators you want, creating custom if need be, and then going ahead and creating this evaluation configuration. And once you've done that, essentially when you move into AgentCore observability, you will start seeing for each of your metrics that you picked over time what the average scores are, the specific number of traces, sessions or traces that have come in on that day, and how your evaluator is scoring, with detailed views both on, if it's a session level evaluator, you can go into each of those sessions and it's going to show you what the score was along with an explanation, as well as nice dashboard for you to continuously monitor what your agent is doing in production.
And here is the score like closer to 1 better or closer to 0 better? Right, so
That depends. This is a trick question, right? Because we saw how to create that scale. So if you make 0 success, that's up to you. But you are essentially defining in your custom evaluator what your 0 and 1 is that your LLM as a judge is going to use. And if you look at the built-in evaluators, you can actually go and see the full definitions of it on our docs. So all of this is completely transparent. You can see how we've defined the rubric. So if you say correctness, for instance, here it's achieved a correctness of 0.5. We also give you an explanation on why it was only scored 0.5. So LLM as a judge is also telling you that it got this particular response from an assistant and why it didn't match the criteria of being successful enough to get scored as a 1.
And there's a prompt template that's actually driving this. That link has been posted in the chat.
So Bharati, don't keep us hanging If the score drops, what do I do?
Yeah, so that is a good question, right? So
So
there
my
are
score
a
is
lot.
now 0. What do I do now? Where 0 being bad?
Yeah. So as a developer, I'm going to go into that specific session, check what happened in that session, and find out how do I improve my agent from here, right? And there are a lot of different ways of improving your agent. The immediate thing you could do is change your system prompt or identify maybe there is something missing in the tool description from like informing the agent that a particular parameter has to be passed and is mandatory, for example. Usually, this is also a lot of work. So I have to go in, manually look at all of those traces and sessions, identify where it failed, and then doing the improvement, which is where agent core optimization comes into play. Um, so I know we're jumping ahead now and getting a little excited about agent core optimizations. So Vivek, do you want to give us a rundown of the aspects that helps me remove all this manual effort into identifying where failures happen and going into improving my agent?
The insights portion, or are we? Do we want to cover recommendations first, building from evaluations?
Let's start with insights, right? So how do I first even, instead of manually looking at each of my evaluation scores, identify where my agent is failing?
Got it. Yeah, so evaluations gives you one signal for what is happening with your agents and if there is an room for improvement. Could be scores are going down, or it could just be that it's at zero point 0.6 and you would want it to take it up to zero point 0.8, and in which case you would want to understand how do I do that across hundreds or thousands of sessions. But you need to have a dimension in mind. It's correctness, helpfulness, goal success rate, or a custom evaluator, say conversation flow quality, as we discuss. But as we discuss, what happens in cases where agent says like, yeah, task successful, I was able to update that database when it did not, or a tool call it returned empty and it fabricated a response for you that, hey, like this is the weather, when the weather API was, that website was down and it did not return any response, so it fabricates data for you. So how do you find these things are happening? And this matters a lot for enterprises, right? Because they don't want agents to give wrong answers or completely fail on their task without giving an indication that this has happened. So your dashboards would be looking 99% green, everything is working, responses are going out, when and essentially a lot of things would be failing, and suddenly you'll get a lot of barrage of complaints of, hey, what is going on? And operationally, what it looks like for developers is, so that's the enterprise level business executives, like, okay, everything is looking green but something somewhere is not working. But for developers who are deep diving into these things and don't have a known dimension in mind, how do they detect and diagnose these errors? How do they find these failures beyond just explicit errors and root cause those across thousands of sessions, when like there are conversations which could have like 1300 spans or 1500 spans, that is, and spans within a single trace. So it took 1300 steps before reverting one single response back to a user. So how do you analyze multiple of these traces within a single conversation? So you need a service to be able to detect these sort of failures, whether those are subtle, implicit, explicit failures, and root cause those for you. So if it's not doing some certain things, there could be 6 different reasons behind it. Root cause those for you and give you clusters of, hey, this is the biggest one, this is the more important one, and this is a small one. So now you would have 2 signals to tell you that something needs improvement, whether that's evaluation scores going down on a known dimension, versus something that you did not know or were not aware of, and now it exists and now it surfaced to you. So 2 signals for you to tell you that something needs to be improved. And now we can discuss how do you do that improvement, because again, it's at that scale, why is this happening? Is there something that something missing from your system prompt, where why is it fabricating a response when the tool did not return a response? Like, is that instruction missing from your system prompt, or the tool description for when to call that tool or how to call that tool is wrong? So is it on the tool description side? Is it on the system prompt side? How many tries does it take for you to get it working, whether that's for a known dimension or an unknown dimension. So evals and insights give you the signals for you to go and optimize and improve your agents, but improving that itself, how do you do that, is a big challenge. Takes a lot of tries, and that's what Bharti, I think we are going to discuss next, and I'm really looking forward to it.
Yep,
Yeah,
from
let me show you a demo, right?
Yeah.
And show you what are the things that eval surfaces. So setting this up is also what it's looking at is observability. So you can point it either to point it either to your AgentCore runtime, so it'll automatically detect the log group, or give it the log group specifically. And it's surfacing three types. The first one is actually those failures, which is what Shoaib asked me. If it failed, should I go in and manually look at these traces? No, it's going to show you the different types of failures along with an explanation and show you those individual root causes of why that failure happened. Now, navigating from here to actually verifying this is quite easy because it shows you all the affected sessions or individually those traces itself. So we're looking at a market agent. It's identifying that there are some reasoning decisions that have failed. The agent one of the mistakes that it made is that it's not identifying the requirements properly. So here, for a particular session number, you can see that it's telling me that it tried to call this particular tool called Get Broker Financial Profile. And then while calling this tool, it forgot to pass in this required parameter actor ID. And specifically, it showed me that span where that tool call also happened without providing that exact span, tool parameter. So this way, instead of manually going and verifying everything, you have basically a cheat book where you can go and look at where it's failing and then go and analyze all of this.
I'll interject here a bit because I'm very excited about the engineering behind it. We built the clustering, the ability to cluster sessions. And the activity that the agent is doing is grouped together at scale as a managed service. And you get a single pane of glass, seeing all of your failures in one place, clustered by all the failures that happened over time. And that kind of visibility is what this provides. And I'll let Bharati talk about the three tabs.
Yeah, so we also have user intents and execution summaries. So this gives you insights into what is your agent doing in production. What are your users querying your agent with? So let's just jump ahead to that. So with the user intents, you can see what are the different topics that users have asked your agent. So this market analyst agent, users have asked it about stock prices, specifically about S&P 500, comparing different stocks and so on. And we'll show you all those individual sessions where you can go and analyze.
These are not failures, right, Bharati? These are not exactly failures. What are these?
Yeah, so the goal behind this is for you to understand what are your users doing with your agent in production. So this gives you the ability. Let's say you want to debug your agent and it is failing in or not meeting the threshold of some of your eval criteria. One of the things you're going to ask yourself is the user using the agent for the intended purpose, right? So this helps you very quickly. It helps you surface that how users have been behaving with your agent. The other thing is execution paths. So let's say they asked about market research and stock analysis or any of those different things. What are the typical trajectories that your agent is following is what you will see under execution summaries.
Thanks, Bharati. You're still leaving me hanging. Where's the self-evolving part?
Yeah, that's
what
a
is
question.
Self-evolving about this?
So what is the other thing you would do, right? Like, let's say you're trying to go and improve your agent. So you're going to look at from all the things that have happened that I've captured in my traces, evaluators are saying, okay, it's probably failing a certain way. I want to go and change my agent, which is like improve its system prompt or its tool descriptions. And that's what recommendations helps you with. So recommendations inside AgentCore optimization. So you go into optimizations console plane, go and find recommendations. And now let's look at what it's doing. So it's going to help you improve the surface of both the system prompt and the tool descriptions. It's going to work on analyzing all of those logs, use an evaluator as a reward signal. So you can see you can do both system prompt and tool description. And here is a core concept. So you have to give it the current system prompt and the tool descriptions. And you can either give it in line and just paste it here, or we have this new concept called configuration bundles. Shoaib, do you want to walk us through config bundles and why we created this?
So, have you ever wished that what if I can override my agent's prompt in real time and try a different prompt as it receives traffic?
So just like how we do like this A, B classification, right? When we have production, right? So we want to be able to shift traffic and understand, right?
It's not just shift traffic. Yeah, it is shift traffic in the sense we have to remember that there is a infrastructure workload. So it's your agent is deployed, it's running on the compute, it is and Java program that's running, Java whatever Python program that's running, but you just want to rip out the prompt and then put a new prompt and then try it with your traffic workload. That's basically what we engineered here with config bundles, and I've not seen that in the industry where you can in real time mutate your prompt and then try out a new prompt that just got recommended or your own override. You could use this completely independently of agent core evaluations or optimizations, where you can do an A/B test of a prompt where the prompt is overridden for an X percentage of your traffic, and it's a real-time override that happens on your production traffic at scale, and this is something that we can do.
Yeah. So we can also you can go in and explore how config bundles are created on the gateway, added, and it helps you do this like live traffic splitting for A/B testing. But let's actually jump back into recommendations, right? So let's create a recommendation. So you're giving a reward signal. So essentially, the reward signal informs what are you trying to improve. So if you pick goal success rate, then the traces and sessions which failed at goal success rate are going to inform how this agent should be improved. So you can pick any of the evaluators, both custom as well, that you've created and provide them. And when you say create recommendation, it's now going to analyze the sessions and traces on your behalf. So let's just add those times between which we want. You can also filter down to the times between which you want those specific traces to be analyzed. And what is going, I'll show you one that's already completed. And let's take a look for the market finance agent again. So it's going to show you your original system prompt where you started. And this is what was currently in production. And now it's showing you some of those data handling gaps that it has found that the agent is not able to perform and is failing due to these reasons. So it adds these very targeted statements into the system prompt, which you can now take to improve your agent. So the next step is, how do I know this is actually going to work? Is where we're going to step into A/B testing. So I'll quickly show you. Setting up A/B testing is also extremely simple. You can go ahead and do different types of A/B testing too. So you can use those config bundles if you've stored them as rules to split traffic between those. What it's going to do is create a gateway in front of your runtime, and the gateway is going to now split the traffic based on whatever percentages you want. So you have the control as your original system prompt or your tool descriptions, and your variant is the new one that you're testing against. So this is going to use evaluations, so online evaluations, and continuously use those metrics on the control and variant and give you the statistical significance of the improvement. So if you see that it's statistically significant to use the new and improved system prompt or tool description, then you can immediately use that as the new configuration of your agent. So this gives you a full set of SDKs to go from observing your agents, evaluating them, putting them into recommendations to keep improving your agents against the production traces, doing A/B tests, so knowing when these recommendations are effective, getting failure insights, so automatically knowing where your agent is failing and going in and constructing this as this full loop that you would need.
Nice, right? So there's a lot that you showed us today, Bharati. We started with defining observability and how things are done, but being able to optimize in real time the prompts, the tool definitions, and being able to shift the traffic to understand how everything fits together. This is all amazing. Thanks for presenting on the show and tell today, and walking us through a live demos, right? So for us to be able to go through.
Thank you, Anil.
Thank
That's
you.
it from our
Yeah.
side today.
Thanks for having
We're
us.
Come back
excited
again.
for you to go and try this out. So have fun with AgentCore evaluations and optimizations.
Yes.
Thanks all.
Awesome. Thanks,
Thank
everyone.
you.